So the first thing that we'll do is that document that I sent out earlier this evening, the loading data. We'll want to bring that up. And so for the engine, we're going to have a point load. So we'll create a nodal group, and it's going to be 15,000 kilograms at x equals 110, y equals 5, z equals 5. So that'll be the location for our engine. So that's right in this compartment here. And if we turn on our nodes, now we haven't cleaned up anything in the parts tree here. Everything is on its own in its own module still. Now that we've assigned properties, if we wanted to, we can start to merge things together. Like for our deck stiffeners and frames, we can move those and merge them in with the decks so that now our deck modules contain everything. And a simple drag and drop onto the decks module will merge our frames, girders, and stiffeners onto the decks, and now they're all contained in one module. And we can do the same thing for the hull. We'll take our hull frames and our hull stiffeners and merge them into the hull module. And now those are all in a single module. As we start using these groups, you can see it'll be very easy to break this back apart if we wanted to go deck by deck. So for our bulkheads, we can go ahead and merge all of those stiffeners and frames into the bulkheads module, and now we just have 3 modules representing our entire hull. And for our engine, it's probably going to be easy. We're going to tie it to the deck. We don't have a foundation modeled, so we'll make the deck our current part, and we're going to want to create a new node, and it's an additional node. Just hit the ID button to create a new one, and we already know the location of it, so we know we're going to use it at 110, 5, and 5. But if we didn't, and we just knew a geometry location in here, like if we knew the engine was located here, we could simply click on that point. And it's actually pretty close. We wanted 110, 5, 5. Now the height is 2 meters because that's the height of the deck, so we would change that to 5 meters above. And we want this at 110. We create that node. And you'll see it's highlighted with a black dot initially. We want to come in and create a nodal group for that so we can assign a weight to it. So we come into the groups dialog and click on the node tab and create a nodal group, give it an ID, and then we can assign a name to it. We'll call it engine. And for a mass, we want to give it 15,000 kilograms. Now this will be the default for this. It doesn't have to be, well, since it is going to be a constant engine weight throughout, regardless of what load case we're using, that engine weight is going to be the engine weight. So we'll never have to worry about changing it. But for things like a cargo weight, for when we do a plate group, that could get changed for different load conditions. But now we'll add just that one node to the group. And you can rotate around to make sure it's selected the right one. And we'll say create. Now, one thing to notice there was the FE tag it was assigned was 0, which is a little odd. Nodes should all have FE tags. Look at that again. We can either use the drop list to bring up that particular nodal group, or if we were looking at it in the groups tree, you can click on it and right click and say edit, and it will bring up the nodal groups dialog with that group selected. If I come in and renumber FE tags, and then I go to edit that nodal group again, you can see now we have an FE tag assigned to it. Now it's the same node ID in this module. That's just the node number in the module, and those aren't necessarily unique. I can have a node 13306 in a different module that would be at a different location, but the FE tags will be unique for each node in space in the model. Now we have that node with a mass, but it is not connected to the deck yet. So we'll create a RBE element. So rather than an R-spline, we could use an RBE2 or an RBE3. The main difference being whether or not the dependent nodes are locked together relative to one another. An RBE2 is going to be basically perfectly rigid, whereas an RBE3 is just going to transfer the forces to the dependent nodes. Since it's an engine, it would have a very stiff foundation and everything. We can go ahead and use the RBE2. I selected RBE2 first, and when I hit ID, you can see it switched back to R-spline. So once you hit ID, then you have to select which type you want. And for my independent node, it's going to be our engine node, that CG of the engine. And then for the dependent nodes, if I had a nodal group or a plate group already defined that was like the footprint, I could just select it here and it would automatically be added. All the nodes from it would be added to the group below. Since we don't have that, I'm going to manually select points. So this is at 110 here. So I'm going to come over 2 frames and go 2 forward, and I'm going to select these 5 nodes, and then I'll go 2 frames to the other side, or 2 stiffeners rather, to the other side, and select those 5 nodes and create that RBE2. So that will be my engine and footprint of where it's getting tied to the hull. Now that weight is not going to be counted in the hull weight for this load condition until it gets added as part of the load case. If I were to come in and view my weight summary again, yes, that nodal group exists. Yes, it's connected to the hull, but it's not part of my current load case. So when I check my current weight for this load case, it's the same as it was before. If I come into the mass group and go on to the nodes tab under mass, you can see the only nodal group we've defined is the engine nodal group. So that one's already listed here. So we'll select it and hit add. If you have multiple groups already created, and this is handy when you're doing the volume groups, add all, and you can add this item just to the current load case. You can add it to all the defined load cases, or copy from one load case to another. This is our first load case, so we're just going to add it to this load case. Whether we add or add all, it won't matter. We only have one defined. For the volume groups, that's very handy to say add all, because if we have 30 tanks defined, you don't want to have to click on them one by one and keep adding them. You can just say add all. They all get added, and you don't have to load them all. You can have them all empty if you wanted. They will just exist in the load case, and you can add volume to them or add weight to them later. So you can see it used the default mass for our engine is already populated in here. If I were to change this, it would ask me about changing the default in the nodal group as well. But I'm going to go ahead and hit modify here to commit that to this load case. And now when I do the hull weight summary, instead of, as we see at the bottom of the screen here, 3.33307, it increases to 336,307. And that was because it didn't increase by 1,500, or it increased by 30,000 because it's a symmetric model. So it added to both sides. So we got two 15,000 kilogram engines added.